Let us look at horizontal stretching. In this case, when we look at the theta over 3, we see that whenever we take a theta value, for instance, if I take 180 degrees, what happens at 180 degrees previously happened at 180 divided by 3, which is 60 degrees. So it means if I look, for instance, at 360 degrees and I want to make a dot at 360 degrees, I have to read off what happened previously at 120 degrees and so forth. So it means that this graph is stretched out horizontally. So the dots that were made here you can't see because it's coincide with the graph, but what we do is we have 1, 2, 3 of them. So half of it is there. So if I change my color here, then that will stay there, and that dot will be there, and that dot will be there. So my graph will be something like this. So it's stretched 3 times in the horizontal direction because I'm changing the B value. I'm changing the B value. I'm not changing the A value, I'm changing horizontally. So let us check on the next page where the graph is drawn electronically. So on this page you can see the purple graph here is the stretched, horizontally stretched graph of cos theta over 3, and because of we divide it by 3, we will now change the period, will now be 360 degrees times 3. Here we divide by 3 and here we multiply by 3. So it's the inverted operation. So divide by 3 and times by 3. So it becomes, the period now becomes 1080 degrees. The roots, we have fewer roots. We can see on the graph here it coincides with F. So that happens at 270 degrees. We have another root at 810 degrees, etc., etc. So, if we look at the amplitude, let us just first do complete the roots. If I look at the roots here, if I want to write down a formula, again, if I want to solve cos of theta over 3 equal to 0, I can let theta over 3 equal to x. So then I just have to solve cos x equal to 0. And I know this x is equal to 2k plus 1 times 90 degrees, as we had before with k as an element of z. So the moment I plug back this theta over 3, so theta over 3, I plug it back there, then I will get my theta will be still the odd numbers, but now it's 3 times 90 degrees. 90 degrees times 3, k element of z. So it will be all the odd multiples of 270 degrees, the k is an element of z. And you can check if k is 0, you can I've just moved the page down a little bit. You can check if k is equal to 0, you'll get the first root that happens at f, and if k is equal to 1, it will give you 3 times 270 degrees, which will give you 810 degrees, and so forth. So if I look at the extremes, we still have just y equal to -1 and y equal to +1, because we did not shift it vertically or stretch it vertically. It just stays the same as you stretched it horizontally. The minima will now be fewer, and we can write down some of it. And like for instance, if you look at q here, looks like a q there. At q we get -540 degrees plus k times, and to get to the next one there, I need to add 1080 times k. That is my minimus where k is an element of z. And my maxima, they are at theta equal to, let me just move it down a little bit again. At theta equal to, let us take the point C there, that is 0 degrees. And to get to the next one, I have to add k times 1080, etc. k element of z. So this is our maximum and minimum and our roots, and we can see on the next page a neat summary of that. On this page you can find a neat summary of how to do a horizontal stretching, and make sure that you know the relationship between the 3 here and the 3 there. So it makes, if I divide the theta with 3, it means it takes longer for the thetas to get to the values that we need. So the period increases 3 times, and amplitude still stays the same because our coefficient of the cos, the a here, is still 1. And I've written out here in red how the divide by 3 changes everything to times 3. So make sure that you understand the concepts here. Please do not just memorize it. Understand the concept, what is happening. And this is about the b value in that general formula.